So I could I could press this button to the end of the word, it will just go. And as you can see, you cannot see where the two pictures are put that together, because probably I now go to, I don't know, 10,000 pixels go, but you can't see where the image actually put together, because yeah, this is the same as the end. Yeah, so probably you know why. Okay, and as you can see, we just go without end. Okay, this was a kind of simple tutorial. As you can see, there is a little white thing there, so if I go, we should see that white thing again. As you can see, here it is. Nice, right? Okay, so that was the first part of this tutorial, and actually we just make this background, which was, I think that it was kind of easy. And the second part of the tutorial will be to show something to a coordinate on the screen. Okay, this seems easy because you just use the SDL blitz surface and blitz something to the screen, although it is not as simple as it seems first, because the background is scrolling, so the foreground should be scrolling as well. Okay, if you just use the SDL blitz surface in normally, you just you can write logos or something to the screen, although you cannot write something that seems to in the game. And yeah, let's get started. Okay, okay, first of all, we need this collision function. This collision function is needed that we only bleed the surface if it is seen on the screen. We don't want to bleed the surface if it is outside of the screen. Logical, isn't it? Okay, the next thing to do is to load the image, because we haven't loaded any images. Okay, I have an image in my desktop called bmp.bmp, so make image equal to SDL load bmp and bmp.bmp. This was probably the first image I made for this tutorial series. Okay, so I just loaded the BMP, and actually I need an SDL rect which contains the width, height and the coordinates of this picture. So SDL rect, I call it img location. Okay, and make it equal to, I don't know, 2000. It starts at 2000 coordinate. So actually when we start the game it will not be shown, but as we go and go and go, as we reach the 2000 coordinate, it will be shown. Actually the 2000 minus 640 coordinate, it will be shown. Okay, the y coordinate is 0, so we show the up on the screen. The width of this image is 50 and the height of this image is 100. Okay, so that's, we just loaded the image and created this img location. Okay, and now nothing, we have to do nothing in here, just in the logic section and the render section. So we have to make a rectangle which will contain the xy coordinates. Maybe it would be better to use don't use the xy coordinate at all. We just use the SDL rect and SDL x and the y, but we already did that, so I will not rewrite the half of the program to do that. So I just define an SDL rect right here in the logic section. So I just use SDL rect and call it I don't know, location. Okay, and it will be equal to x and y. Alright, and the width is 640 and the height is 480. Simple enough, we just set the location. Okay, and we need one more thing. We need the relative location of the image. We have the absolute location of the image. It has 2000 coordinate, but that cannot be shown on the image, so we have to calculate what the coordinate of the image. Obviously we have an x coordinate and a y, so if we go to 2000 coordinate on the x, then our image should be shown at 00 coordinate, as you may guess. So to demonstrate it a little, here is the game, and as you can see, this is our screen. I hope you can see the selection. So its thing which we will show, it is in this coordinate, and because it is outside of the screen, we will not show. We will do that in a moment. So as we go like that, in here, approximately in here, it starts to show because it is inside the screen, and we need a relative coordinate. We have the absolute coordinate. For example, this is approximately 1500 coordinate, but whenever I get here to show it like that, it will be at 00 coordinate, as you can see. As I go back, for example in here, it will be approximately the width of the screen minus the width of the image. So we have to calculate the relative coordinate. If you do not understand that, just draw it and you will understand why we will do what we will do. Okay, so we need to create the relative coordinate. I call it SDL relative coordinate. Okay, our relative coordinate, the x will be the location of the image, so img loc, I think that's what I called it, dot x minus the x of the x where we are. So for example, if we are at 2000 coordinate and the img loc dot x is 2000 coordinate, we will show it in 0 coordinate and in x, and y, we will not really use y in this demonstration, although I always just write y, so I will not make an exception here. So img location y minus y. Okay, the width and the height is not really matter here, because this will be just tell where the coordinate, so where it is in the screen. Okay, so if we are at 180 at x in the x location, then we draw this image to 200 coordinates. So if you don't understand, draw it and you will understand. I always say that. Okay, and now we have to check the collision. So collision, I mean under it that we want to draw one image if it is in the screen. Okay, so we have two squares here. One is the screen, which is actually ready, and one is the rectangle of the image, so this square. And we just simple check to collision. If there is a collision, then it is inside the screen. Okay, so if we go, then here it will be collision, so we start to show the image. If we go out, if we go inside, there is still a collision, but if we go out like that, then there will be no collision, and we know we don't blit this image, because why would we blit the image if it is not on the screen? Okay, so if, and we use the collision function which we defined up there. So the first is the camera, actually not the camera, the location. So that's what we defined right here. So location, the address of location, because this collision function waits for the address. And the second is actually the location of the image, so img loc, if I remember well. So if there is a collision, then we use the SDL blit surface function. The first parameter is the image, the second parameter is what part of the image do we want to show. For now we will just press null, and the next parameter is the so where do we want, so we want it directly to the screen. And finally the last parameter is the location, where do we want to write it, so this will be the rel code. Okay, and that's all we need to do, actually, I think. Okay, I just write the x coordinate out. If it is not work, then we can find out what the problem is. So x coordinate x, and just make a new line. Okay, so that was it. I think I did everything. Oh, what a memory leak. It is incredible. I forget to even delete the background, so sorry about that. If you use a graphical IDE, it probably said that there was a problem, so yeah, I make a little bit of memory leak, but don't worry too much. Okay, so SDL free surface background and SDL free surface image. Okay, we free the surface, and now we can start the program. Okay, try to compile it and run it. Okay, as you can see, it is already held that we write out the x coordinate. It wasn't defined, at least according to this, although it is defined. Then what is the problem? Oh, I know what the problem is. I hope the keyframes are okay. So we made this and x and the y variable earlier for the mouse demonstration, and I forget to delete those variables, and because these were defined in here, that was changed the value of the x. So I think that it should solve the problem. So yeah, it is x0. So try to move, and as soon as we reach the 2000 minus the width of the image screen coordinate, we should see this weird image, or not. Okay, we reach the 2000 coordinate, and I cannot see any image. Alright, then what is the problem? Okay, we loaded the bmp.bmp image. We set the coordinate. Oh, I think I know what the problem is. We have to make this to the render section under the background, as the background will rewrite what we have drawn to the screen. So yeah, that was a weird problem, and I forget to go from the logic section to the render section. So we always first draw the background, draw what is in the background, and that's we have to do. So now we can compile the program and probably run it, and as soon as we reach the 2000 coordinate, we should see this weird man I drew by myself. Oh, you see, it is there. It is like it would be the part of the game, actually. As you can see, when I move, moving, it stays there. If you will just simple draw it somewhere. So that's the main thing about the SDL about the scroller we will make in SDL, so side scroller game, which we will do. So as you can see, we can go away, and now probably it is not drawing because it is outside of the screen. As I get in here, it is drawing because, you know, there is a collision, and then we draw it. So we will do that with every single part of the side scroller. Actually, I will make the side scroller from little squares, so everything will be squares, and we just check the collision of the squares, and basically that's it. So that was for this tutorial. Thank you for watching and have a great day.